Now let's take a look at a couple more theorems about trapezoids. One works for isosceles trapezoids, and the other works for all trapezoids. The first of these theorems is the isosceles trapezoid diagonals theorem, which says if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. In other words, if quadrilateral QAD is an isosceles trapezoid, then segment AQ is congruent to segment UD. Let's take a look at how we can prove this. Let's start by taking a peek at these two triangles here. Triangle AQU and triangle DUQ. They overlap each other, and they happen to share a common side, namely segment UQ. So by the reflexive property, segment UQ is congruent to segment QU. Now, we also have the isosceles trapezoid theorem, which states that if a trapezoid is isosceles, then the base angles are congruent. So angle AUQ and angle DQU are a base angle pair, so they are congruent. So let's take a couple seconds here to recap. Quadrilateral QAD is an isosceles trapezoid, and we know that segment UQ is congruent to segment QU by the reflexive property. And by the isosceles trapezoid theorem, we know that angle AUQ and angle DQU are congruent. Now, it may be a little bit difficult to see here, so what I'm going to do is I'm going to pull our two triangles out so that we can look at them separately. Now that we've pulled these two triangles out away from each other, can you see the congruent markings on them? Notice that we have a pair of congruent sides, and another pair of congruent sides, and a pair of congruent included angles. That makes these two triangles congruent by side angle side. And finally, all of their corresponding parts are congruent as well. That means that segment DU and segment AQ are congruent. And that's by the definition of congruent figures, and a lot of people once again like to call this CPCTC. So notice once again, the segment that joins the midpoints of the legs of a trapezoid. So notice that a trapezoid has exactly one midsegment. The midsegment is parallel to the bases, and the length of the midsegment is the average of the lengths of the two bases. The length of the midsegment is equal to the base lengths divided by 2. In other words, the average of the base lengths. So now let's plug in some values. wind up with 33 plus 6, which is 39. Then we are going to wind up with 88 minus 47, which is 41. Our solution is indeed t equals 11.